All right, so let's see some consequences of thermal expansion when talking about filling up a gas tank. All right, so why you may see gasoline dripping from the nozzle at a gas station, right? So let's suppose it's a hot day. Gasoline starts off in the tank in underground a gas station, right? Not sure if you knew that's how they hold the gas, but it is. There's a giant tank underground. Now, temperature underground is going to be cooler than the temperature above ground. All right, so gasoline cools the steel tank when it's filled. All right, so both the gasoline and the steel tank expand as they warm to the air temperature, but the gasoline expands much more than the steel, so it may overflow. All right, so that's why it would drip from the nozzle, right? Is because the gasoline would expand larger than the nozzle mechanism. Now, what's also very interesting is that thermal expansion is going to affect your gas gauge as well, right? When there's a certain kind of minimal volume of gas in your gas tank, that's when your empty light turns on. So how do you think thermal expansion affects this? So, can you drive more miles on empty in the summer or in the winter? What do you think? So, because gas expands more than the gas tank itself with increasing temperature, you can't drive as many miles on empty in the summer as you can in the winter. In the summer, the gas decreases its density because it expands as compared to the winter. So there's going to be less gas molecules to burn in your summer tank when you're on empty. Don't worry about this. So, in summary, we can say that temperature is a quantity that's measured by a thermometer, right? We learned that absolute zero is when there's no molecular motion. We've learned about 3 different temperature scales, Celsius, Fahrenheit, and Kelvin, which is the SI temperature scale. We can use conversions to change from one scale to another. We learned about the 0th law of thermodynamics. So, actually I have that later on, but we talked about thermal equilibrium and why thermal equilibrium occurs at a microscopic level. And then I wrote down the 0th law there. We learned about thermal expansion, how it can increase or decrease the size, being a length, area, or volume, actually, and how it's directly proportional to change in temperature. So thermal expansion is going to be large for gases and relatively small, but not negligible, for liquids and solids. And finally, we looked at a formula for linear thermal expansion. All right, so I hope that was helpful.